Welcome. Today, we shall discuss the topic Simple Machines 2. By the end of this lesson, you should be able to define load, effort. You should be able to explain mechanical advantage of a machine, define velocity ratio of a machine and its efficiency. Then solve simple calculations on machine and also talk about the uses of simple machines. Okay. What is load? Anytime we talk about simple machines, the term load and effort is an occurrence. We want to get exactly what load is. So load is the force overcome by the machine. The load is denoted by a capital letter L. Since load is a force, the unit of load is Newton. The effort is the force applied to a machine to lift or overcome the load. The effort is abbreviated with capital letter E. Since effort also is a force, its unit is in newtons. Let's talk about some terms that we use in describing a machine. Number one we want to talk about here is mechanical advantage of a machine. Even in simple terms as the word advantage. What is the advantage of using this machine? Remember that in my previous lesson, we've discussed the meaning of machine. I told you that a machine is a device or a tool which makes us to do our work easily and more conveniently. So if you are using a machine to do your work, what is the advantage of using this machine? So if a machine amplifies the effort you put into this machine, that means that the machine has an advantage. For example, if you are using two cutlasses, one is blunt and the other is sharpened, and you are given the same piece of land to cut, you agree with me that someone who is using the well-sharpened cutlass will finish the same piece of work very fast and with less stress because the machine is using to do the work has an advantage. So we can say in mathematical terms that mechanical advantage of a machine is the ratio of the load to the effort applied on the machine. So since mechanical advantage is load over effort, I told you previously that load is a force and effort is a force. Therefore, we can also call mechanical advantage of a machine the force ratio. Mechanical advantage of a machine has no unit. Just like you know, load is measured in newtons and effort is measured in newtons. So if we have newtons divided by newtons, the answer is 1. Therefore, a mechanical advantage of a machine has no unit. I need you to take note of that. So don't be tempted to, adding newton or any other thing to mechanical advantage. It has no unit. Is that okay? Now, the mechanical advantage of a machine depends on friction. Friction affects mechanical advantage of a machine. If a machine, has a lot to do with friction, it means that most of the useful work you put into the machine will be used first of all to overcome friction. So you see that if a machine, that particular cutlass I was talking to you about that is blunt, you will now have to apply a lot of effort to cut the same piece of land. So when that happens, you'll be exhausted. So friction affects the mechanical advantage of the machine. Please, I need you to take note of that. Usually, that comes out in almost all the examination we write in BESE. Okay, take note of that, that friction affects mechanical advantage of a machine. Because friction affects mechanical advantage of a machine, the mechanical advantage of a machine cannot be 100% because of friction. Look at this, for example. This man is carrying a load in a wheelbarrow, and the load in that wheelbarrow is equal to 300 newtons. And the effort the man has applied to lift a load of 300 newton from where he is to a distance is just 100 newtons. Have you seen that because the wheelbarrow they are used is a simple machine, that wheelbarrow has amplified the man's effort. Imagine he's applying an effort of 100 newtons to carry a load of 300 newtons. I hope you can say now that the wheelbarrow is of a great advantage to the person carrying that load. So if you calculate from what I have told you already that mechanical advantage of a machine is that it is load over effort, you can see that the wheelbarrow amplified the man's effort 3 times. Because if you say mechanical advantage is load over effort, so if we substitute that the load carried by this man is 300 and the effort he has applied is 100. So we can see that 300 over 100 is something as 3 all over 1. 3 over 1 is something as 3. So the mechanical advantage of the man is 3. We can also call mechanical advantage a leverage. So that anyhow it is brought, you should be able to tackle it. It is mechanical advantage is the force ratio. It's also known as leverage. Please take note. Force ratio, leverage, mechanical advantage. These terms, they mean the same thing. Okay. Velocity ratio of a machine. The velocity ratio of a machine is defined as the ratio of the distance moved by the effort to the distance moved by load. Also, velocity ratio of a machine has no unit because distance is measured in meters. So distance moved by effort is in meters, distance moved by load is in meters, distance over distance, meter over meter, sorry, is equal to 1. Therefore, velocity ratio has no unit. The velocity ratio of a machine is not affected by friction. Friction does not affect it. Rather, it is affected by the design of the machine, or what you say, the geometry of the machine. That's what affects the velocity ratio of the machine. So mathematically speaking, we can say that velocity ratio is equal to distance moved by the effort all over distance moved by load. So if from previous example I gave you in mechanical advantage, if that man had moved the load in the wheelbarrow a distance of 100 meters, for example, and by the time he lifted the wheelbarrow from the ground, before he pushes it forward, he had also lifted it a distance of about 300 millimeters, sorry. Now, from here now, all we need to do here is to see that 300 millimeters, which is distance moved by the effort, divided by 100 millimeters, which is distance moved by load, will give us the velocity ratio of the machine. Don't bother yourself that you're seeing millimeters and I did not convert to meter, because both the distance moved by effort and distance moved by load, they are all in millimeters. So there is no point converting it to meter because both of them are in the same millimeter. But if I don't have it in millimeters, I will convert it to SI unit of distance, which is meter. Okay, so that is it. Efficiency of a machine. The efficiency of a machine is the percentage of the work put into the machine that becomes work output. I will say it in another way you can understand. The efficiency of a machine is the ratio of work done by the machine all over the work put into the machine. Mathematically speaking, we can say that the work done by the machine, we can also call it work output. That is, if you apply an effort in a machine, what that machine is able to do for you is the work output. You understand? Okay, so efficiency of a machine is the ratio of work output to work input times 100/1. Please take note of this. The efficiency of a machine is measured in percentage, because for us to measure it, it must be what's the percentage of the efficiency of this machine. You can see from what I'm saying here that efficiency of a machine and mechanical advantage, they seem to be related to each other, because any machine that has a mechanical advantage, automatically it's efficient to use the machine. But a machine that doesn't have mechanical advantage, there's no point, there's no efficiency using the machine. So we can also say here that efficiency of a machine is also given by mechanical advantage of a machine all over the velocity ratio of the machine. Please take note of this formula I'm giving to you. Efficiency of a machine is equal to mechanical advantage of a machine all over the velocity ratio of the machine times 100/1. The efficiency of a machine is also affected by friction. Friction affects efficiency. Therefore, there is no machine that has an efficiency of 100%, unless theoretically a machine we call an ideal machine. That ideal machine, let's say that that machine is not affected by friction. Therefore, the work put into the machine, the work output, and the work input will be the same thing, such that the efficiency of the machine is 100%. But aside that, no machine has an efficiency of 100% because of friction. Because part of the useful work you want to put into the machine will first of all use to overcome friction, then to overcome also the load. So that is why no machine has an efficiency of 100%. Let's take this example and calculate the efficiency of this machine. What is the efficiency of a machine that has a work input of 400 joules and a work output of 35 joules? I need you to understand that anytime you are given any problem to solve, you need to bring out the parameters given. It will enable you to know which of them to place where to place. It makes it easier for you to bring out, also memorize or remember the formula to use. Now, from what I have here, I have it that work output parameters given work output equals 35 joules. Work input equals 40 joules. Now, we are asked to calculate the efficiency of the machine. So we will state the formula that will enable us to calculate the efficiency, which is that the efficiency of the machine is equal to work output over work input times 100 over 1. So all we need to do here is to substitute the values. So when we have it, we have that efficiency. We have that efficiency equals work output here is given as 35 joules. So we will write it here as 35 joules all over work input. Okay, so we have 40 joules times 100 over 1. You know that 5 can go into 35, and 5 into 35 is 7. 5 into 40 is 8. Therefore, we now have it that efficiency of this machine is equal to 7. We can even go further. Yes, we can even go further so that we need to just bring it down. You know, let's see. 2 can go into 8. We can even use 4. 4 can go into 8 and the answer is 2. 4 can go into 100 and the answer is 25. You understand? So we have that 7 times 25 all over 2. So here we have that 7 times 25 equals 175 divided by 2. 175 divided by 2 equals 87.5. Remember that I told you that efficiency of a machine is expressed in percent. So we will have here that efficiency is equal to 87.5%. Can you see that this machine actually is efficient to use? Okay. Example, simple calculations. Let's take general calculations involving mechanical advantage, velocity ratio of the machine, and the efficiency. Example 1. Okay, let's take simple calculations that involve our study. If the mechanical advantage, for example 1, if mechanical advantage and velocity ratio of a machine are 6 and 8 respectively, calculate the efficiency of the machine. So I said that the first we'll do, you see now, the first we'll do is to write out the parameters so that will inform us what and which formula we are supposed to use to solve the particular problem we want to solve. So in this case, we were given that mechanical advantage, please let us abbreviate, all right, that mechanical advantage, MA, of a machine equals 6. And its velocity ratio, VR, equals 8. We are asked to find the efficiency of the machine. So efficiency, we don't really know it. So given these parameters, remember I told you earlier that efficiency of a machine can also be obtained using this formula, that mechanical advantage of a machine all over velocity ratio of the machine times 100 over 1. So given these parameters, that formula is what we are going to use to solve the problem. So we are going to state the formula. It's one of the ways you do it. You must state the formula that you are using to solve the problem. So efficiency equals mechanical advantage of the machine, MA, all over velocity ratio of the machine times 100 over 1. So the next thing we'll do is to substitute. So we have efficiency equals MA here is given as 6, so we'll substitute it 6. Velocity ratio 8. Then times 100 over 1. Of course, you know that this is something as saying 3 all over 4. So we have it that efficiency of a machine is equal to 3, that is 2 here, 3, right? 2 into 8, 4. This is 3 all over 4 times 100 over 1. 4 here, 1. 4 into 100 is 25. So the efficiency of the machine is equal to 3 times 25, and 3 times 25 is equal to 75. Efficiency of the machine, therefore, is equal to 75%. That is how to calculate that. So whenever you are giving mechanical advantage and giving velocity ratio, please remember this formula. That is the formula to use to solve the problem. Example 2. A machine with a mechanical advantage of 7.5 is used to overcome a load of 150 newtons. Calculate the force applied. Okay, the force applied, as we have in this question, is the same thing as effort, because effort is the force applied to the machine that the machine uses to overcome the load, you know. So force applied here is the same thing as effort. Please take note of that. It's important you take note of that. Okay, the same thing we did before. We're going to write out the parameters. Here we're giving mechanical advantage MA as 7.5. Also, load L, capital letter L, equals 150 newtons. We are required to calculate the effort. So effort is something as force applied. Effort E is what we are looking for. We don't know it, but we already know from what I told you that mechanical advantage of a machine MA is equal to load all over effort. So what we need to do here is to substitute. Mechanical advantage is 7.5. Load, as given here, is 150 newtons. No need of writing the newton. I hope you understand. Yes, no need of writing the newton. So all over effort, which is what we are looking for. So we'll make this one here to also look like a fraction so that we can handle it. So in this case, we're having that 7.5 is the same thing as saying 75 over 10. So we say 75 all over 10 equals 150 all over effort. So we can comfortably cross multiply this now. So we have that effort, 75 times effort, so we can say 75 times effort equals 150 times 10. 150 times 10 is 1500. You don't need to even bother yourself about it. Just take this 0 and add it. That is the answer. So this is 75 effort equals 1500. Since we are looking for effort, we have coefficient of effort here 75. So we're going to divide both sides by 75. So divide both sides by 75. We have it that 75 or 75 is 1. 1 times effort is effort. Okay, so we have that effort is equal to 1500 all over 75. You know that 1500 over 75, we can have it done with ease. Okay, you know that 75 here into 150 is 2. Just take this 0. 75 here, 1, 75 here, 2. So the effort, therefore, is equal to 20 newtons. Remember that effort is actually a force. So the unit of effort is Newton. Please take note of that. Very, very important. Example 3. The efficiency, a machine whose efficiency is 60% is used to lift a load of 500 Newton to a lorry when an effort of 100 Newton is applied on it. Calculate the velocity ratio of the machine. So first is to write out the parameters. The parameters will give us a direction to which formula to use and what to do to get what actually we are looking for, what we're asked to calculate. So we write out the parameters. So in this case, we have parameters given. So we have from here, efficiency of the machine is given as 60%. Load, L, capital letter, is 500 newtons. The effort, E, applied is equal to 100 newtons. We are asked to calculate the velocity ratio of the machine. Therefore, velocity ratio, VR, of the machine, please we'll abbreviate this subsequently. VR is what we are looking for. So now the question you ask yourself is, what is the connection? What's the connection that exists between among velocity ratio, efficiency, and load and effort given? I told you that efficiency of a body is given as mechanical advantage, MA, all over velocity ratio of the machine times 100 over 1. But here, we don't have mechanical advantage, but we have two parameters that can enable us calculate mechanical advantage. So what we'll do first is to calculate the mechanical advantage. Is that okay? Okay, so let's calculate mechanical advantage and put it back in this formula. We'll get what we're looking for. Therefore, mechanical advantage, MA, is equal to load all over effort. So first of all, calculate this and put it back here. We'll be able to get the value of velocity ratio as we are required to do. So mechanical advantage, MA, of this machine is equal to load is 500, while effort is 100. 0 will take care of 0. 0 will take care of 0. 5 all over 1 is the same thing as 5. MA, mechanical advantage, is equal to 5. Bringing it back, please take note that I said that mechanical advantage is equal to 5. Let's have it here, that MA is equal to 5. Substituting it here, we have that efficiency as given, which is 60%. 60 equals MA as calculated 5 all over the velocity ratio we are looking for, you see, times 100 over 1. We have fraction now, 5 times 100, V times 1, V. So we have that 60 is equal to 500 all over velocity ratio, you see. So divide this 60 by 1 to make the two sides of the equation to look like a fraction or to become a fraction. So in this case, we will cross multiply. So we're having 60 times velocity ratio equals 500 times 1, which is equal to 500. Divide both sides by 60. Divide both sides by 60. So 60 over 60 is 1. 1 times velocity ratio is the velocity ratio we are looking for, which is equal to 0 here. We'll take care of this 0. Therefore, velocity ratio is equal to 50 all over 6. So, what is 50 all over 6? The velocity ratio of this machine, therefore, is equal to 8.3. What is the unit of velocity ratio? I know you have an answer. Remember, velocity ratio has no unit. So don't be tempted to put units to it. Uses of machines. Simple machines has so many uses. We can't even exhaust it. For example, an inclined plane is used to lift heavy loads up to a height. For example, you want to lift a drum of oil to a lorry. With the head of an inclined plane, either metallic or wooden, with little effort applied, that's done. Okay, it gives you less stress. You just roll up the drum of oil in the lorry you want to, load it. The pulley, for example, is also used in lifting heavy loads. In building construction, we have pulley used especially when we want to construct very tall buildings. Pulley is utilized in these areas to carry heavy load up that height. We can also use pulleys, if you've seen, you can use pulleys to lift heavy load, like I said. If you have seen some construction sites, maybe where they are constructing skyscraper, there's usually that machine that has a hook. I know you must have seen it. That machine that has a hook that they use to lift slabs and heavy load, that is a pulley. So pulley can be used, even in elevators of a building. Pulleys are used in that area. A lever, for example, bottle opener is a type of lever. We need bottle opener to open our drinks. Maybe we just want to cool off. We need that opener, so we can use lever in that area. A lot of things. Remember, wheelbarrow too is also a type of lever. So wheelbarrow too is used to carry heavy load from one place to another. A whole lot of uses of machines. Now, this is an example of somebody who is trying to use pulley to lift heavy load. The screw jack, we use screws to fasten a woodwork, even metal work in some cases. So that machine we call the screw jack or the screw. We can use it to fasten. We can use them as fasteners. The screw. Yes, we also use the wheel and axle to draw up water from the well. That is the practical application of that wheel and axle. Those days that we have well, you can just use wheel and axle to draw up well. Okay, so let's take some examples from ExamGuide app. Remember, ExamGuide app is app for every learner. If you wish to smash your basic examinations, I recommend you to practice often with ExamGuide app. Okay, let's practice some questions. Based on what I've taught you in machines, let's see some questions from ExamGuide app. Okay. The diagram below shows a lever. Identify parts labeled A and B respectively. So, this part labeled A, if this is a lever, let's see. Option A, the fulcrum, load. Is that what it means? This point labeled A, does it represent the fulcrum and B represent load? Option B, the fulcrum and pivot. Option C, group and load. Option D, load and pivot. Option E, pivot and effort arm. Okay, let's answer it. B, of course, you know, is called the load that is on the lever. The point labeled A, is the pivot. Why this entirely? In case you are asked some other time. So we have the right option here. Option A. A is our pivot, otherwise known as fulcrum, and B is the load. So option A is the right answer. This is called a beam or bar. This is called a beam. It could be wooden or metallic. So this is where you apply an effort. This is the load. So here is the fulcrum. A jack, a screw jack, is a type of simple machine. A jack as a simple machine is dash A or and dash. Okay. Is it option A, efficiency multiplier, B, energy multiplier, C, force multiplier, D, power multiplier, E, work multiplier? This option is option C. Why? I just told you here that a machine that has a mechanical advantage amplifies effort applied, and effort is a force. So option C is the right option, you know. So the machine amplifies an effort you have put into the machine. Okay, let's see this. A jack lifted a vehicle of 2,500 kilograms with an effort of 50 kilograms. What is the mechanical advantage of the machine? Now, that means we are going to make some calculations and find that out. Remember that I told you in the course of my class that mechanical advantage of a machine, MA, is equal to load all over effort. But in the question, they gave us masses. They gave us the mass of the vehicle and the effort applied as mass, because that unit you are seeing there, kilogram, is for mass, not for force. But we know that force is equal to mg, where g there is acceleration due to gravity. It's actually 9.82 meters per second square, but approximately 10 meters per second square. So we're going to use that. We're going to use the approximated value of g to solve the problem. So in this case, MA, the load there will be the weight of the vehicle. So this is going to be 2,500 times 10, which is for acceleration due to gravity, all over effort applied. The effort applied here is 50 times 10. Are you not seeing that this 10 can take care of this 10? So we'll still solve and get our answer, you know. Okay, so we have this 0 takes care of this 0. This 0 here takes care of this 0. Therefore, mechanical advantage of this machine, therefore, is equal to 250 all over 5. But 5 can take care of 25. 5 here, 1. 5 into 25 is 5. Therefore, option A is the right option, 50. Mechanical advantage of that jack is 50. No unit. Take note of that. So you can also go ahead to practice more questions, you know, on your own to see how you can, you know, navigate through the questions. I'll see you in my next class. Sam Brown.